Okay, quadratic formula. Again, it's got to look like this to start with, then you apply the formula. We're going to do one example, and the example we're going to do is kind of a hard one, but if you can do the hard one, you can do the easy ones. So we'll jump in with a difficult one, and pretty much they get easier after this. 18 minus 6x equals 7x squared. Okay, quadratic formula experts on the first problem. What should I do first here?
Move the 7x squared.
I need to move something around. You can move the 7x squared if you want, or you can move the 18 and the 6x. It doesn't matter. If you move the 7x, you're only having to move one thing, but I like my lead coefficient to be positive, so I'm going to move the other stuff over. But it doesn't matter. If you move the 7x squared over, that's okay. I'm going to move the 18 and the 6x over. 7x squared plus 6x minus 18. Now, I'm going to do this once to emphasize the importance of it, but I'm pretty sure you're not going to write this down every time. But it's important, so we'll take a minute on this one to specifically call out who's A, who's B, who's C, and then we'll use the formula. Again, after we write them out one time, you're probably not going to write them out, you're just going to use them. Lannon, what's A equal to? 7. I'm glad you said 7. Anyone care to guess what the usual wrong answer for what A is? 7x squared. Well, I mean, again, you're looking at the first term, but A is the number in front of the x squared, not including the x squared. Addie, how about B?
B is 6.
B is 6. And Kira, how about C? Negative 18, very nice. She grabbed the negative with it. Now we've got A, B, and C. We're ready to plug them in. If you need to write those out, write them out. Most of you, though, are just going to look at it, and you can just identify by looking who's who and jump straight to the formula, and that's certainly okay. So x equals negative b, negative 6, plus or minus the square root. B squared would be 36. Minus 4ac all over 2a. When I said this one's the worst, this is what I mean. Like the math computation in there is kind of yuck. We're gonna use calculators eventually. Not today, though. I want us to get used to even multiplying by hand when we have to. It gets us used to what the operation looks like, what our answer should look like. That way, when we do go to the calculators, you're not just like a slave to the calculator. Hey, whatever the calculator spits out has to be right. Like, no, you need to understand what you're putting in, what you're getting out. And to do that, we're going to do this one by hand, even though it's ugly. 4 times 7 times 18. I don't know what that is. I do know what 4 times 7 is. 28. And then times 18. We do like the old school multiplication here. 3rd grade, 4th grade type stuff. 8 times 8 is 64, carry the 6, 2 times 8 is 16, plus 6 is 22. Put a 0 down there to hold the spot. 28 times 1, that's an easy thing, that's 28. So 4, 0, 5. Okay. Annoying, sure, but good practice. And again, this is the worst one. Most of the other numbers are smaller. So negative 6 plus or minus the square root of 36. What's the sign going to be here? Positive. So 2 negatives will make a positive. So kind of saving space here. I'm going to add 36 and get 540. 540? I don't know any perfect square factors of 540. Who knows if he even has any perfect square factors? So we're going to kind of factor tree this thing. It may have been a while since you've seen a factor tree. Are there any perfect squares of 540 you can think of?
4.
Definitely 4. So let's do 4. So 4 and then 540 divided by 4 is 1. 3 times 4 is 12. Did that right? Nope. Bring down the 20 and get 5. Yes, 4 and 135. All right. Well, that's good, I guess. How about 135? Is that? And if you don't see any perfect square factors, and you probably don't, because I don't, is there any number that goes into 135 that's pretty easy to recognize? 5. So let's divide by 5 and see what that gets us. So 135 divided by 5. Let's see, 2 times 5 is 10, 35, 27. Oh, because 27 is 9 and 3. Now, you could split this up a whole bunch of different ways. Like, factoring a big number like that, there's a whole bunch of different ways to do that. But now I can see that 540 is 4 times 9 times, we'll put the 5 and the 3 back together. 4 times 9 times 15. And again, we like the 4 and the 9 because those are perfect squares, and we can square root those. So let's see. That would be 2 times 3 is 6, and 15 left over. So that was kind of ugly, handling the 540. Oh, I'm not done with that. I can simplify by 2. So negative 3 plus or minus 3 root 15 over 7. How many answers is that? 2. Right. And you don't have to write it 2 separate ways. People kept asking that on the test. I'm like, no, there's 2 answers there, and I'm okay with that. Leave it like that. The only time you do need to split it up is if you got down to like 2 plus or minus 4. You're like, well, do 2 plus 4 and 2 minus 4. But if you got square roots or i's, just leave it alone. Be done. All right, we'll do some more of those in a minute, but we'll just do them off of the homework to get us a kind of jump start on that. One more piece of a piece of the formula that's important is the b squared minus 4ac part. Highlighted and didn't show either one. There's b squared minus 4ac. There it is in the whole formula. I just want to kind of call that out and look at it because that controls some things. What does that... It's maybe too open-ended of a question. Okay, it's what's in the square root. So how does that factor into what type of answers we get? Okay, exactly. If it has I or not, what would make it have an I in it? Negative. If that was negative. All right, so now we're on track here of looking at what b squared minus 4ac means. I don't know if you've done this before or not. Do you know what it's called? It's a fancy name. Discriminant. The discriminant. You're not really going to need to... Well, I guess you will need to know that name because we'll say, find the discriminant. First period asked, oh, does it discriminate? Like, well, it actually does, that's the name, but not like on the basis of race or gender or national origin or religion or any of that stuff. No, it discriminates based on what kind of answers you get. So, yes, that's sort of where the word comes from, and yes, that's kind of what it means. It just doesn't have a negative connotation. It's just helping us figure out what our answers look like. So we'll start with what you noticed first, and that is if it's less than 0, if it's negative, then we'll get 2 imaginary answers, or 2 imaginary solutions. Because you'll get plus or minus the square root of a negative. This is one of those things where most people don't really memorize this. I mean, maybe you remember, you need to know that b squared minus 4ac is the discriminant, but then you can figure out the rest, because you know it comes from the square root, so if it's negative, an I is going to show up. What about if it's 0? What happens then? That seems like a weird case. How many answers do you get if it's 0? You don't get 0 answers. You get plus or minus 0. But what's the difference between plus 0 and minus 0? Yeah, nothing. That's the same thing. So if b squared minus 4ac is 0, then your one answer, you get one real answer. One real solution. It's a repeated root. We're not really worried about that yet. You get one answer. Oh, by the way, that happened on the test. It was one of the multiple choice ones. You factored it, and you got the same answer twice. You know the one I'm talking about? Okay. And so the answer to that one, I think, was not, the answer is not there. Because it gave you all the wrong, it gave you some bad choices. And the answer was, it was only one answer. And you didn't use the quadratic formula on that one, but you would have gotten 0 for the discriminant, and then plus or minus 0 gives you one answer. All right, well, the last case, if b squared minus 4ac is greater than 0, what happens then? Two real solutions. You get plus or minus something real. Maybe something weird with a weird square root, but still something real as opposed to imaginary. So I'm not really going to box and star this because I don't feel like this is a memorized thing. And this is if you understand where b squared minus 4ac comes from and what it does in the equation, then you can pretty easily figure out what kind of answers you'll get based on what your discriminant is. Okay, so now let's turn back to the worksheet and just work some together off of the worksheet. Number 1, find the value of the discriminant of each quadratic equation. Of course, there's only one there. You know what? Before we do that, at the very top of the page, I'm going to write the quadratic formula one more time, just because writing it out helps force it into your brain. It might help you memorize it quicker just by writing it one more time. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And then you've got the discriminant sort of built in there, so you don't need to really write that again. If you want to highlight it or sort of call attention to it, like, oh, there's the discriminant part. Okay, now number 1. Find the discriminant of this thing. So b squared minus 4ac. So 3 squared minus 4 times negative 4 times negative 2. I didn't even think about it, but I did not write down A equals B equals C equals. If you need to, do it, but you're probably fine at this point. 3 squared is 9. 4 times 4 is 16. Times 2 is 32. What about the sign of 32? Negative. Yeah, 3 negatives make a negative. We don't use that rule very often. Negative times negative is positive. One more negative makes it negative. So 9 minus 32 is negative 23. And this problem sort of feels incomplete because that's all it asked for, so we're done. There's solutions to be had. We know there would be imaginary solutions, but that's all it wanted us to do. 2 through 5, find the discriminant, but then say, give the conclusion, how many answers do we have based on that, and what type of answers do we have? So let's do number 2. What do you want to do first on number 2? Yeah, move the 7 over. So 3n squared minus 5n plus 7 makes minus 8. Why don't you try that one? So find the discriminant, and then once you find the discriminant, figure out what that means in terms of your types of answers you have. And 3, and 4, and 5 is just finding the discriminant, and then if it's positive versus negative versus 0.
How do you know it's 2?
Because this is positive. So you don't really, at this point, you don't really care what the value is. You only care if it's positive, negative, or 0. Now, when we want to find the solutions, it would matter that it's 121, but that's not for this particular problem. What are you going to have to do first on number 3? Move the 9 over. So do number 3. Move the 9 over. No, you can, if you can divide everybody by 5, it will make your life, or 3 or 2 or whatever, it'll make life a little easier. Makes it a lot easier. It is 0. Colin, what does that mean? If b squared minus 4ac is 0, there's one solution. Again, you're not really memorizing that. You're thinking back to the equation and realizing if you do plus or minus 0, that's kind of the same thing, so you get one answer. All right, let's skip 4 and 5 and jump ahead to number 6. Solve each equation with the quadratic formula. So now we get to do the full thing here. Looking at number 6, 120 looks terrible, but what could we do first on number 6? Let's divide by 3. Much easier numbers to deal with. Right, so sing the song in your head. What's negative b going to be? 3. Good. 3 plus or minus the square root. B squared will be 9 minus 4ac all over 2a. Alright, this isn't terrible. I mean, it's better than 4 times 3 times 120 anyway. 4 times 40 is 160 plus 160 square root 169. Did any of y'all have those mean teachers that made you memorize the perfect squares up to like 25? Aren't those teachers terrible? Except that now you know what the square root of 169 is. 13. Yay for mean math teachers. 3 plus or minus 13 over 2. Oh, and this would be an example of one where we don't want to leave it like that because we can take that further. 3 plus 13 is 16 over 2, 8. 3 minus 13 is negative 10 over 2 is negative 5. So if there's nothing more you can do, then leave it. But if there is more you can do, keep going. Thank you. All right, turn to the, whoops. Let's do a couple off the back. Make sure we hit some of these. First thing I'd say now that we're looking at the back is we already did 15. That was example 1. So go ahead and mark that one off, unless you just want to do it again. That was the ugly one. Let's look at number 12. Seth, what do you want to do first on number 12? 3p squared minus 5p plus 10 equals 0. So can't simplify by anybody on this one, so we're stuck with p equals rather than x equals negative b plus or minus the square root. Side note, here's why we are not using calculators yet. It's because when it comes time to square negative 5, some of you are going to grab your calculator and type in negative 5 squared like that. And what's the answer to what I wrote down right there? That's negative 25, because that squares the 5 and then attaches the negative, which is what you're supposed to do. That's what you told the calculator to do, as opposed to squaring negative 5. That would be 25. So that's sort of part of the reason I don't want to give you a calculator yet, because you're just going to start punching buttons in and getting answers that don't make sense. So b squared minus 4ac C all over 2A. Okay, 25 minus, oh, they're big, but this isn't bad. 4 times 3 is 12, times 10 is 120. 25 minus 120. Whoops, here's why I picked this one. What's going on under the radical there? Yeah, it's negative, there's going to be an I. So 5 plus or minus, so we can do 2 steps at once here. I square root 95 over 6. 95. That was a confident, you can't simplify that. You sure? You said it confidently. Let's see. We'll definitely divide by 5. 25s is 100, so 19 5s is 95, and you can't do anything with either one of those. So yeah, you were right. We can't simplify that. But be careful, because you always got to look and see if you can, and then if you can't, you can leave it alone. Let's do one more. Let's look at number 14. Again, I'm going to move things over so that A is positive. If you don't mind A being negative, you could move the 3x squared over and have negative 3x squared. Everything would still work. You'd still get the same answer. I just prefer A to be positive. Oh, what can we do next on 14? Divide by 3. So I'm going to hit pause. Why don't you divide by 3 and then see if you can take it start to finish. Negative b plus or minus the square root of b squared minus 4ac all over 2a. 4 plus 16 is 20. Okay, here's where people started going crazy. 2 divided by 2 is 1. That's true, but you can't do that yet because it's all over 2. So you can't reduce that yet. You can't reduce the 2's. You got to fix the 20 first. 2 root 5 over 2. Now you can divide by 2. And here's another mistake. What's 2 divided by 2? I mean, everybody knows it's 1, but that means you got to write the 1. It doesn't just become plus or minus square root of 5. 2 divided by 2 doesn't just like go away. 2 divided by 2 is 1. Alright, this is one of those where, like, kind of like the last test. There's 100 steps. I think someone counted 11 or 12 on one of these problems, like 11 or 12 little bitty math problems. But you got to get them all right to land at the right answer. Assignment is the rest of this worksheet, so 1 through 17. We've obviously done a chunk of them already, so hopefully that's not too bad for your weekend.